Hi, I'm Alejandro, an RF engineer with National Instruments. And today I want to show you how you can take advantage of NI's test and measurement platform to tackle some of the new challenges of working with 5G cellular signals. Some of these challenges include new, higher bandwidth in more complex signals, and having a modular test platform that allows you to capture all the data these signals produce. Here in my lab setup, I have a PXI chassis, an embedded controller, and a vector signal transceiver with 1 GHz of real-time bandwidth. The VST can both generate and analyze high bandwidth waveforms, which help you prototype, validate, and test your new 5G designs. Here in my LabVIEW application, I use the RFmx new radio API to generate and analyze a 100 MHz cyclic prefix OFDM single component carrier waveform with a subcarrier spacing of 30 kHz. The new radio API makes it easy for you to write code to analyze the spectral and modulation accuracy performance of your 5G devices. I click here on the Adjacent Channel Power tab, and I can see the carrier and the 2 adjacent channels along with the measurement results. Now I go over to the Modulation Accuracy tab to see the 4 QAM signal and EVM characteristics. A big challenge when working with 5G new radio signals is the new standard numerology. So now I'm going to select a 2-component carrier signal with 60 kHz of subcarrier spacing and using 256 QAM. I click the button to generate the signal, and now I can go to the Adjacent Channel Power tab to see the spectral results. Notice here the 2 100 MHz carriers next to each other and the 2 adjacent channels. I can also go to the Modulation Accuracy tab and see that the API is giving me results for 2 component carriers. Now I'm going to switch over to a 4-component carrier signal, occupying a total of 400 MHz of instantaneous bandwidth. In this case, I'm also using 60 kHz of subcarrier spacing and 256 QAM for every subcarrier. I generate the signal, and now I can go to the Adjacent Channel Power tab to see the signal occupying 400 MHz of bandwidth and the 2 adjacent channels. I can also go to the Modulation Accuracy tab and see the results for each component carrier. This is a quick example of how you can take advantage of NI's test and measurement platform and the flexible and extensive RFmx new radio API to characterize, validate, and test your 5G designs. To learn more about 5G, please visit ni.com/5G.